Welcome to the lesson on trigonometric identities. At the end of this lesson, you will be able to state 3 basic trigonometric identities. You will also be able to apply these trigonometric identities to solve problems. Here is a triangle ABC. By the angle sum property of triangles, we know that the angle A plus angle B plus angle C is 180 degrees. This equation is true in all triangles. An equation that is true for all values of the quantities that it contains is called an identity. Since the equation angle A plus angle B plus angle C is equal to 180 degrees is true for all triangles, this equation is an identity. Consider the right-angled triangle PQR. By Pythagoras' theorem, we know that in the right-angled triangle PQR, the sum of the square of the sides PQ and QR is equal to the square of the hypotenuse PR. Now, let us derive some trigonometric identities by dividing both sides of equation 1 by the squares of different sides of triangle PQR. Let us start with the hypotenuse PR. Let us divide both sides of equation 1 by PR square. Since the numerator and the denominator are the same, the right-hand side of the equation becomes 1, and we get equation 2. If angle R in triangle PQR is equal to theta, then the ratio PQ upon PR is equal to sin theta, and the ratio QR upon PR is equal to cos theta. Putting the values of these ratios in equation 2, we get an equation sin square theta plus cos square theta is equal to 1. This equation is a trigonometric identity. This trigonometric identity is true for all values of angle theta from 0 degrees to 90 degrees. Now, consider side PQ, the opposite side for angle theta. Let us divide both sides of equation 1 by PQ square to get equation 3. Now, in triangle PQR, the ratio QR upon PQ is equal to cot theta, and the ratio PR upon PQ is equal to cosec theta. Putting the values of these ratios in equation 3, we get an equation 1 plus cot square theta is equal to cosec square theta. This equation is a trigonometric identity. From the trigonometric ratios of specific angles, we know that cot 0 and cosec 0 are not defined. Thus, this identity is true for all values of angle theta greater than 0 degrees and less than or equal to 90 degrees. Now, consider side QR, the adjacent side for angle theta. Let us divide both sides of equation 1 by QR square to get equation 4. Now, in triangle PQR, the ratio PQ upon QR is equal to tan theta, and the ratio PR upon QR is equal to sec theta. Putting the values of these ratios in equation 4, we get an equation 1 plus tan square theta is equal to sec square theta. This equation is a trigonometric identity. From trigonometric ratios of specific angles, we know that tan 90 and sec 90 are not defined. Thus, this identity is true for all values of angle theta greater than or equal to 0 degrees and less than 90 degrees.